Negative exponents, algebra 2 trigonometry regions. All right, so negative exponents. Basically, negative exponents mean reciprocals. And a reciprocal is flipping a fraction upside down, basically. Like the reciprocal of 2 over 3, its reciprocal would be 3 over 2. There's nothing about changing signs or anything like that. Sometimes students think reciprocal is flip and change signs. What you're actually remembering is perpendicular slopes are what we call negative reciprocals. But basic reciprocals are just flipping upside down. It's nothing to do with changing signs. And so when you have a negative exponent, this is the properties, but basically you just reciprocal your base. So a negative exponent means reciprocal base. That's the key. So if you have something like x to the negative a, but let's give it a number. Let's say 5 to the negative 2. What you want to do is not even worry about the 2 aspect of it. See, when you deal with negative exponents, you kind of have to deal with it in 2 steps. First, you have to deal with the negative piece, and then you have to deal with the 2 piece. So now this could just be typed into our calculator, but I just want to practice the properties with you a little bit. So the negative piece means reciprocal base. So 5 is not a fraction, but we know it could be made a fraction by simply putting it over 1. So if you think of it as 5 over 1, the reciprocal of 5 is then 1 over 5. And that is the reciprocal of 5. So the negative means reciprocal base. The reciprocal of 5 is 1 over 5, and we still have the 2. So when we reciprocal the base, the negative exponent becomes a positive and regular exponent. And we deal with that just like we deal with every exponent we've been dealing with for years. So when you have a negative exponent, again, you want to reciprocal the base, and that'll make your exponent positive, and then you may need to apply that. So what is 1/5 squared? 1/5 squared is 1/25. It's, squared, 1 squared is 1, 5 squared is 25, and so that would be the final answer. Now, if you have something that is a fraction, like we said, 5 is 5 over 1, but what if it was, 3/5? And 3/5 to the negative second. Well, it's just exactly the same. The negative part means I need to reciprocal the base. And so the reciprocal of 3 over 5 is 5 over 3. And then once I reciprocal my base, I turn my exponent from negative to positive and apply that as we always have. And 5 squared is 25, 3 squared is 9, and that would be the final answer. So we're going to look at a couple of examples here. But the key is negative exponents mean reciprocal base. So what is the value of 5 to the negative 2? Of course, this is one that I just happened to do. I forgot that this was the next example, but I want to think of this as 1 over 5, the reciprocal of 5, raised to the positive 2. And 1 over 5 to the positive 2 is 1/25. It's important to know that it does not make base negative. So I'm going to add that here too. Does not make base negative. All it means is reciprocal the base. If your base is positive, its reciprocal is positive. If your base is negative, then your reciprocal is negative. But it does not change the sign of the base. All it does is flip the base upside down. It reciprocals the base. So 5 to the negative 2 is not going to give me a negative number. A lot of people, oh, maybe it's negative 25. That's not how it works. My base is positive. My answer is positive. All I did was reciprocal and then apply the squared. And again, your calculator can do this for you. If you type in 5 raised to the negative second, it will give you the answer, but it'll do decimal. But if you hit math and then enter twice, your calculator will convert that decimal to a fraction for you. 2a to the negative fourth. We discussed the importance of parentheses in the past couple of lectures. So both 2 and a are being raised by this exponent here. And so the negative part of it means I need to reciprocal the base. Now 2a is like 2a over 1, so its reciprocal is 1 over 2a. And now it is being not raised to the negative fourth, but to the positive fourth. So to deal, again, it has nothing to do with the 4. The fact that it's negative means I reciprocal the base to make my exponent positive. and applying this to that. So 1 raised to the fourth is 1, and 2a raised to the fourth, 2 to the fourth is 16, a to the fourth is a to the fourth. So there we go. Okay. Did not make my base negative or anything like that. And it's key that the 2 was also being raised to that. The parentheses made a big impact there. Otherwise, the answer would have been B. If, say it were, say the question was 2a to the negative fourth without parentheses, then I would only reciprocal the base a to the bottom. But parentheses made it reciprocal the whole thing. A couple more. Now this one has a bunch of negative exponents, but you need to kind of deal with them one at a time. And just like yesterday, when we have a bunch of things going on, we kind of do the outside stuff first. So the outside of this is a negative 2, so that means I'm going to reciprocal the base right away. So what's on top goes to the bottom, bottom to the top. Everything keeps what sign it is. So 3x to the negative third is now on the bottom. 5y to the negative second is on the top. And then 3x to the negative third is on the bottom. So I reciprocaled this base, and now it's raised to the positive second. And it should be pointed out here that there's several order in which you could do this. I could simplify this and then do that, or I could simplify this and do that. Even here, I can now deal with these, or I could apply this too. So there's a lot of ways to go about these. As far as the order, that doesn't really matter. I'm going to continue working out to in. So first I dealt with the negative exponent out here. I made it positive by reciprocaling its base. Now I'm going to deal with the 2 out here, which is squaring everything in here. 5 squared is 25. And that would be y to the negative fourth, remember exponent raised by an exponent, negative 2 times 2, over 3 squared is 9, x to the negative 3 times 2 is negative 6. And now I have negative exponents here that require to be reciprocaled. But again, notice that this isn't 25y being raised to the negative fourth. Only the y is being raised to the negative fourth. So I just need to reciprocal this piece, which basically means move it to the other side. And this x to the negative 6, then needs to move that to the other side. It needs to go to the other side of the fraction. That's what reciprocaling does. And so the 25 is not being raised by any negative. That's going to stay where it is. But the x to the positive 6th, by reciprocaling this negative 6, brings it to the top as positive. The 9, not being raised to anything, stays where it is, but the y to the negative fourth, when reciprocaled, comes to the bottom as positive 4. So 25x to the 6 over y to the fourth. So this is complicated. There's a lot going on here, and again, you can do this in multiple steps. If you think it would be easier to ignore this first and deal with this, reciprocal these negative exponents and then reciprocal the whole thing in square. That's it's up to you. There's a lot of, like I said, a lot of different ways in which you can do this as far as order goes. But the negative means flip this base, and by flipping it, I didn't change anything signed, just the top went to the bottom, bottom went to the top. Squaring it is, numbers squared, exponent raised by an exponent means multiplication, and then to deal with variables with negative exponents, they basically, by reciprocaling, they go to the other side and become positive. One more example. This one has a negative exponent, but it also has a fraction exponent, which we talked about in the last lecture. So first, don't pay any attention to the fraction, just deal with the negative. So this negative means I need to reciprocal my base. My base is 9x squared y to the 9x squared y to the 6th. Its reciprocal would be 1 over 9x squared y to the 6th, and that whole thing raised now to the positive 1/2. And we know fraction exponents from yesterday that the bottom is our power. So this 2 really means the square root of 1 over 9x squared y to the 6th. And the 1 on top means raised to the 1, which doesn't really do much. So we're square rooting all this stuff. And the square root of 1 is 1. The square root of 9 is 3. The square root of x squared is x. And there's 2 ways to think about that. We could divide by 2. And you could also think at it from this stage. Remember, an exponent raised by an exponent means multiplication. And 2 times 1/2 is 1. 6 times 1/2 is 3. Or you could think the square root of y to the 6th, where we divide by 2. Either way, y to the 3rd. And so that is the answer a. So I dealt with the negative by reciprocating the base no matter what, and then the fraction exponent, like we did in the previous, means, the bottom number is a power, a root, in this case a square root, and that got us our final answer. All right, so we'll play with this concept of negative exponents tomorrow.